So today's lesson for Thursday, January 11th, if you're here in class, is going to be about inequalities. So we've gone over equations, which is chapter 3, which are in a way very similar to inequalities, and you'll see why. So before we start actually going over the definitions and the components of inequalities, I want to give you an example of inequality, how one would read through a problem and then write the inequality that represents that problem. So here I've got something written down. It says, each day at lunchtime, at least 53 people buy food from a food truck. Write an inequality that represents the situation. So this is a very short problem. It says each day at lunchtime, at least 53 people buy food from a food truck. But there is some important information in here, such as the fact that at least 53 people buy food from a food truck. That term right there is giving me a ton of information because it's saying that I'm either going to have 53 people or more than 53 people, but I'm never going to have less than 53 people, because saying at least is to say that the minimum number of people that are going to come visit my food truck is going to be 53, but I might have more than that. So the question wants us to write an inequality that represents the situation. Now, an inequality, just like an equation, has two sides. So inequalities have a variable side, so a side with a variable, and then a side with a number, usually just one number or an expression. We haven't gotten to the point where we have two variables or where we have two sides with x's on them. So now let's figure out, what do I need to put in between here? And that's what's new with inequalities, that we're not going to be using equal signs with inequalities. If you see an equal sign, it's an equation. So something like x is equal to 5, that's going to be an equation because of the equal sign. But with inequalities, we're not going to be using any equal sign. We're going to be using other symbols that you've seen, such as less than or greater than, and then two new symbols, which are less than or equal to, or greater than or equal to. And I'll show you what that means right now. So if x represents, let's say that x is going to represent the number of people that come visit my food truck. So x equals the number of people. So if x is the number of people that come visit my food truck, in this scenario, x is either equal to 53, or because I'm going to have at least 53 people, that means I can also have x, the number of people that come visit me, be greater than 53. So in that just small sentence here, at least 53 people, tells me that x is going to either be equal to 53 or is going to be greater than 53. And I can actually also represent that on a number line. Because I'm being told that, again, x is either equal to 53, I'm going to put a circle there, or it's greater than 53. So I'm going to show an arrow, which is a line that represents the numbers just continue to move on. I could either have 53 people or I could have an infinite amount of people. But the important thing here, excuse me, yeah. So the important thing here is that I'm never going to have a number that is less than 53. And thank you for those of you who said bless you, even though this is a video. So now I've written this in two different ways. I've written it with two different, one being an equation and the other being an equality. And then I've also represented it on a number line. But I can't use an equal sign in an inequality, which is what we're working on now, because that makes it an equation. And equations need to be different from inequalities. So what we do actually to represent this is that we can actually put those two together and write it as x is greater than or equal to 53. So notice how this is kind of a mix of the equal sign and the greater than sign, except for I'm only showing one of the bars of the equal sign. And so that's just how we represent in this math kind of sentence that there is an equal sign, but we're not going to put it just on its own because that makes it an equation. So this reads as x, the number of people that come visit my food truck, is either greater than 53, so maybe 54, 55, or is equal to 53, but is never less than 53, because that would look like this. That would look x is less than 53. Notice how these signs are different. So that is just an example of how you would read through, how you would reason through an inequality. So now that you've gotten kind of an idea of